In this video, we're going to look at aldehydes and ketones. We're going to begin by looking at the structure and the naming of aldehydes. An aldehyde contains this functional group. Carbon-oxygen double bond joined to a hydrogen. It is sometimes written like this. Now clearly, this structure doesn't show how the atoms are bonded together, but it's written like this to avoid any kind of misunderstandings with alcohols, which are clearly OH groups. When naming an aldehyde, it's important to remember that this carbon is always carbon number 1. And for that reason, we don't actually need to put a number to show where the position of this functional group is, because it is always carbon number 1. So if I were to draw this structure, I can see 1, 2, 3, 4 carbon atoms. So this clearly would be bute, and because all the carbon-carbon bonds are single bonds, al, alpha aldehyde. When we move on to a ketone, the ketone has some similarities to an aldehyde in that it also contains this functional group. But in this case, it is sandwiched between carbon atoms. So were I to name this particular ketone, I will be able to see 1, 2, 3, 4, bute, and when we're naming ketones, butanone. Now, because this isn't always going to be on a particular carbon, clearly it's never going to be on carbon number 1, the position of this group can move through the chain. So let me give you an example. If I were to think about this, 1, 2, 3, 4, 5, 6, I'm clearly going to have hex, and all the carbon-carbon bonds are single bonds, and on carbon number 2, I have my ketone group. So the number tells us the position of the functional group. In this particular case, it could only ever be on number 2. So you will sometimes see it called butane 2-one, sometimes it's just called butanone. If in doubt, put the number in, because usually the number is needed. When we look at the bonding in aldehydes and ketones, we can see that this carbon is bonded to 3 other atoms. And that's true for aldehydes and ketones. Pause the video and have a think about what the bond angle and what the shape around this carbon atom will be. Okay, because it's bonded to 3 other atoms, we can clearly see that bond angle, as all of them will be 120 degrees. Just because this is 2 pairs, 2 covalent bonds, they effectively occupy the same space in terms of shape. So we've got 120 degrees, and around this carbon atom, the shape is going to be trigonal planar. The next thing I want to talk about is the chemistry of aldehydes and ketones. After all, we are chemists. Think about this functional group. Pause the video and consider what kind of behaviour will this functional group show and why. Okay, what you should know is that there is a difference in electronegativity between the carbon and the oxygen, and that's going to result in a polar bond. Delta negative oxygen, delta positive carbon. Slight positive charge on the carbon atom. The reason being because of this increased electronegativity of this element, the bond pairs are going to be pulled towards the oxygen atom. So we've got a delta positive carbon atom, and that's really going to control the chemistry of this set of compounds, of aldehydes and ketones. Collectively, aldehydes and ketones are called carbonyl compounds. And this is the carbonyl group. If I were to put an oxygen atom here, and you'd see that in things like carboxylic acids and esters, the presence of the oxygen atom modifies the behaviour of the carbonyl group. And so strictly speaking, when we're talking about carbonyls, we're only discussing aldehydes and ketones. Let's get back to this delta positive carbon atom. What kinds of things are going to be attracted towards the delta positive carbon? Things with lone pairs of electrons. Because an entity with a lone pair of electrons is going to be able to form a bond to this delta positive carbon atom. Now, it may be that that entity, that thing, has a negative charge on it. Whatever it is, if it has a lone pair of electrons and it's able to donate those and form a new covalent bond, that is going to be called a nucleophile. Now we can break this word up into two bits, nucleo and phile, from the stem philus. Nucleo, positive, phile, loving. So it's a positive loving entity. Don't write that on the exam paper though. On the exam paper, the definition of nucleophile is a lone pair donor. This is the basis of the mechanism that we're interested in for this area of chemistry. We're dealing with nucleophiles, which are going to attack the delta positive carbon atom. And as that occurs, the pi bond in the carbon-oxygen double bond will break, and the pi bond electrons will move onto the oxygen atom. More about that in a later video.